Cool. Hey everyone. So I'm Alex from Delve. I'm our lead protocol engineer, and we're good. Okay, cool. So we're going to be talking about Hyperdrive today. Hyperdrive is a fixed rate AMM that we built. So if you're not familiar with fixed rates, basically the idea is given $1, you can lock in a fixed rate of return for some amount of time. So let's say that the term length is 1 year and the fixed rate is 5%. So if you had $1, you could basically put that dollar to work in Hyperdrive and you'd get $1.05 at the end of the year. So what Hyperdrive does is it actually prices the fixed rate. So as people buy more of these long positions, which is the position that receives the fixed rate, you're going to get a lower fixed rate. And as people short more bonds on Hyperdrive, it's going to drive the rate up. And so we have, kind of a natural market force of people buying and selling these bonds, and that's going to adjust the fixed rate over time. Hyperdrive can be integrated into all kinds of different protocols. So we can build it on top of Aave, Compound, any kind of lending protocol, staking protocol, stuff like that. So basically, it's just converting variable rates from staking protocols or lending protocols into fixed rates. And there's a bunch of cool things that you can do with Hyperdrive. So for example, you can fix a borrow position. So if you have let's say you're borrowing $10,000 on Aave, and you're going to have some kind of variable rate of interest that you have to pay. If you purchase a short on Hyperdrive for the same amount of dollars, it's actually going to lock you into a fixed rate. Because as the interest rate goes up on Aave, you're going to be earning more money on the short. And if the interest rate went down on Aave, you're going to be earning less money. So it actually ends up being the case that the fixed rate that you paid to open your short position is the only interest you have to pay over the course of the term. So that's just one example of kind of the magic of fixed rates. We're really excited to see what you guys come up with over the course of the hackathon. And come by the Delve booth and we'll kind of share ideas about how we could build cool stuff. So if you go to the GitHub Delve Tech, you're going to see our open source Hyperdrive repo. This is where the smart contracts live. We also created a Hyperdrive Solidity starter repo. So this is just kind of like a repo that you can use to get a primer on how to integrate with the smart contracts using Solidity. So I'll try to keep things relatively quick. If there's questions, we can talk about how to use this later. But it's just a normal Foundry repo. We have some instructions here about how to build and use it. And it just includes a simple hello world example. So what this hello world does is it just opens a long position on Hyperdrive and then logs some data about it. And if you run our hello world test, which you can do with forge test VV, this is all in the README, it's actually going to run this example on a live pool that we have set up on mainnet, which is the SDI pool. So that's just kind of a nice way to get started. You'll know that you're actually able to open a long. We're over the course of the hackathon, we'll also spin up opening a short and adding liquidity. So in the event that you need to use any of those primitives for what you're building, you'll have this example set up and we can help you kind of add custom features to it. But yeah, that's pretty much it on the Solidity side. Like I said, look at our GitHub, look at our bounties, and come to the Delve booth, and we're happy to help you with any and all of this. So I'm going to pass it to Danny, and he's going to talk a little bit about building front ends with Hyperdrive.
Thanks. There it goes. Cool. Hey everyone, my name is Danny. I am the lead front-end developer here at Delve. Like Alex mentioned, I just want to walk you through our Hyperdrive starter mono repo. So if you're interested in building front ends, and I'm just kind of curious, how many of you have built a front end, a Web3 front end of any kind? Maybe used VM or WAGMI or React. This will probably look familiar to some of you. But I want to just, walk you through this a little bit and then also show you the existing front-end Hyperdrive to maybe kind of solidify some of these concepts that Alex mentioned about the longs and the shorts. So before maybe jumping into the starter repo, I want to show off the hyperdrive front end that we have today. And like Alex mentioned, we've got different pools on hyperdrive where you can open up a fixed rate or a variable rate position. So a good example here would be maybe the Lido Steth pool. And in the Lido Steth pool, you can see that if I were to spend 1 ETH in this pool, then I would receive about 1.1 and some change ETH at maturity. And you can see that it matures on the 18th of April. So I can just kind of buy this position, hold it in my wallet, come back in 6 months, and I'll have earned effectively about 3% on my ETH. And this is really great because it's kind of a set it and forget it yield position. If the fixed rate changes over time, you're locked in. You already bought your long. And as far as a counterparty for this, which is a really great question we got at our booth, so definitely come by if you have questions, and we'll be happy to answer them. The counterparty to this would be the short side of the market. And so if you are interested in variable rates, instead of the fixed rates, you could open a short. And in this example, let's say I want to earn yield on 1 ETH worth of deposit into Lido, then I only have to pay 0.015 ETH for that exposure. So you can see that over time, the longs and the shorts kind of work together and create trading volume in this pool. And depending on how much liquidity is in the pool, that will determine the size of the long or the size of the short that you can open. The third side of the market, because this is an AMM, this is going to be the supply side. So if you are interested in depositing into Lido, you could kind of use hyperdrive as a sort of a surrogate for depositing into Lido, because when you deposit your ETH into hyperdrive as liquidity, you will effectively be earning the Lido Steth rate on your deposit, and you're going to also earn trading fees whenever users open longs and shorts. So it's kind of a way to boost your exposure to Lido simply by being an LP on hyperdrive. So there's some really cool market dynamics that you can explore with both the longs, shorts, and then as a sort of a long-term position being an LP on hyperdrive. You'll notice that the longs and the shorts have maturities, so they will expire at a certain point, and then you can close those positions. Whereas if you're an LP on hyperdrive, you can just sort of set it and forget it. And as more people open longs and shorts, again, this being a 6-month pool, you don't have to do anything about rolling over your liquidity or any type of stuff like that. As an LP, it's pretty straightforward, and it'll feel a lot like just depositing in Lido. So this is the front end that we built for hyperdrive, and I want to now spend some time talking about the starter repo that we wrote to kind of just give you a head start. You're not obligated to use this if you're interested in building on hyperdrive, if you have a stack that you prefer. But I want to just kind of run you through this a little bit. This is using Turbo Repo, which is a way to structure. It's really nice for front ends because you can have apps and packages living in the same repo. Turbo Repo is made by Vercel, and their docs are fantastic. So don't want to spend too much time on that. But here in the README, and we'll jump into VS Code here in a moment. Here in the README, we've got some links here for you. So like I mentioned, if you want to build your own project from scratch, not use this as your boilerplate, we've got the Solidity starter repo linked here. We've got the front end that I just showed you. That entire front end is open source. So if you see something that you want to use, but that isn't yet in the starter repo, you're welcome to just go snatch our React hooks or whatever it is. Happy to help you crib off of the official front end repo. Then we've also got the contract ABIs. This will be things you're familiar with, especially if you use tools like VM and WAGMI or Ethers. You can just npm install our ABIs. You don't have to go hunt them down on Etherscan or anything. And then we've got this app config package. This is going to be where we keep all of our static metadata. So if you've ever like gone through and had to make an RPC call for decimals and name and symbol, that is all captured in the app config. It is just a giant JSON object. You're welcome to console log it and see all the good information that's in there and kind of save your alchemy bill. And then we've got a fixed point math library. You're welcome to use whatever one you prefer, but this is one that we use in the Hyperdrive official front end. So if you need to multiply, the longs by their fiat price, to show that to your users, this is a great library for that. And then we've got our Hyperdrive SDK, which we'll see here in a minute, as well as VM bindings for that SDK. If any of you have ever used SDKs as a front-end developer, a lot of them go stale or they end up like with an outdated version of a Web3 library. So there's a really great way that we've architected this so that you can write your own bindings. And in this case, since VM kind of has the lion's share of usage for front end, we've gone ahead and already written VM bindings for the SDK. So that's kind of just kind of walk you through the README. Now I want to jump into VS Code real quick and just kind of walk you through what we've got here available to you out of the box. Can you all see that all right in the back? Cool. Okay. So real fast, we have a package here called Core. The configs here, you probably won't need to touch those. But here, if you're interested in building some sort of developer tool, like a library or your own SDK, we've gone ahead and created a simple little package that it already has a build script. It's got TypeScript included, and it's an empty index file at the moment. But if you want, like I said, to build just an NPM package on Hyperdrive, this could maybe give you, a 6-hour head start on bootstrapping a TypeScript project. But I think more interesting here is going to be this front end that I mentioned. So just to kind of scroll through the package JSON real quick, got some basic Vite scripts, or Vite if you're an Anglophone. And we've got React query, some those packages that I mentioned. We'll look at those in a second. Rainbow Kit, if you've ever used Scaffold ETH, a lot of this stack is going to be similar to that. And I would definitely suggest going to Austin Griffith's talk on Scaffold ETH. He's a really great resource. Daisy UI is a component library. You're welcome to use whichever one you like, but this one's nice and lightweight. It's also written with Tailwind, so if you're familiar with Tailwind as a component library, it'll speed you up. And then since Vite does not have, it's unlike Next.js, it doesn't have its own router. We've gone ahead and included tan-stacked router for you if you're building a front end and you're going to have multiple pages. And again, the docs for all these libraries are extremely detailed. I think that's about it. That's what I need to cover here as far as what you get out of the box. So I want to go ahead and just jump into the folder structure here. And so here in the source directory, we've got our network just to start. So we've already created the query client for you. We've already created the WAGMI client for you. We are deployed on multiple chains. So if you want to build on the Ethereum mainnet pools, that's what this one's going to come with out of the box. If you do want to build on the Gnosis chain pools or the Linea or the base pools that we've got, you'll just want to add your own transports and RPC URLs to this WAGMI config. That might save you just a little bit of time. And then we do have a .env here with the mainnet RPC URL. If you want to integrate Wallet Connect, you'll need a project ID. And that's pretty much what you need to just get started. I've already gone ahead and done that before we started. So let's go ahead and just run this, and then we'll break down the code a little bit and set you loose. So this is the example front-end app. I made it ugly so you can make it pretty. And right now we're reading some information from the contracts. We're reading some of the information from that app config package that I mentioned. So right now there's 17 pools deployed across 4 chains, and then the first pool in that list is that Steth pool that we just looked at. And we can see that in real time, we've got some data coming from the SDK around the TVL of this pool. So I want to just walk through real quickly. We've got about 1 or 2 minutes left. Here in the SDK folder, we've gone ahead and added a get read hyperdrive and a get read write hyperdrive. You shouldn't need to edit these. You can just call them in your hooks. And then here in the UI directory, we've got our main.tsx. This will look very familiar for anyone who's done front end. But right here, that's where our code is going to live, and the rest is just going to be package code. And so here in the home view, this is what you just saw. Not going to go through all this JSX, but I do want to walk through some of these hooks just real quickly. All of this is documented, so feel free to read the comments here. But for that TVL number, I got to do a speed run here. For this TVL number, we have a used TVL hook, and that's calling that get read hyperdrive. And then from there, you can call get present value, which is going to give you that total value number that we saw in the front end. So this read hyperdrive is worth exploring. This is the entirety of the SDK in a single class. So if we were to look at all the other goodies that we can ask the smart contracts, you can, for example, get fixed APR. That might be a good one if you want to see what the fixed rate is for the longs. You can make your own custom hook that calls get fixed APR. And a bunch of other goodies in here. If you want to build a portfolio, you can grab a user's positions and build that front end. So I think I got to call it here. But again, if you want to come by the booth, we can chat about this, nerd out about front end development. We'd love to talk to you. So yeah, thank you.
This is some serious production here. This is great. All right. Hi, everyone. I'm Lance LaChance. I'm a product manager here at Rootstock Labs, and today we're going to cover a bit about Rootstock. Rootstock is the first and longest Bitcoin sidechain. And so what we generally refer to Rootstock today, we're an L2. In purest terms, there's no such thing as a Bitcoin L2. But some of the key things to understand about Bitcoin, we're secured. The network is secured by Bitcoin miners, so around 60% of the network is merge mining Rootstock. We're fully EVM compatible, and I think this is very important in ETHGlobal here. Everything you do on EVM land, you can do on Rootstock, but with Bitcoin as the asset. And so really this brings kind of the value proposition and story of Bitcoin and DeFi coming together. DeFi on Bitcoin is what Rootstock brings. And so the security and store value of Bitcoin with the compatibility and programmability of Ethereum is what we're bringing. And so why Rootstock? So compatibility, we've talked about. All the smart contract and dApps that are built on Ethereum can be easily ported and brought into Rootstock. All the token standards, ERC20s, the 721, 1155, all those are compatible in Rootstock as well. From a security perspective, this is, I think, where we really strongly differentiate and establish ourselves. We have arguably the most secure Bitcoin bridge in the world. We use a defense in depth mechanism using hardware security elements and a decentralized federation model for this. And we also secure the network with the Bitcoin mining network. So this is a process called merge mining. We have a shorter block confirmation time of 30 seconds, but we still get the security of 60% on average. It's a market-based condition. We're always bringing on new miners, but around 60% for the past year has been merge mining Bitcoin, or Rootstock rather. And then the store of value story of Bitcoin, right? I think this is the core driver of Bitcoin as an asset. And really what we're looking at is how do we bring this asset into more productive use cases? And this is really where Rootstock comes in. And there's no native gas token besides Bitcoin on Rootstock. So you can deploy other tokens. We have other tokens on Rootstock, but gas is paid in Bitcoin. And this also brings us economically aligned with the Bitcoin network. Around 80% of the gas fees on the network are being paid to the Bitcoin miners. And then scalability. I think this is, Bitcoin doesn't have the smart contracts capabilities, and that's what we bring, but we also bring faster confirmation times. So right now we're around 30 seconds. In the future, in the next year or so, we have a proposal to drop this to around 5 seconds. And then our transaction fees are around 20 cents present day. So lower transaction fee costs in the Bitcoin network, faster confirmation times as well. And so in the ecosystem, we have around 400 million in native token value locked. We've been live since 2018, 100% uptime, no security incidents. And so we're very confident and happy with the performance of the network. So you can see some of the other stats here, but happy to talk about any other questions on the state of the network. And so when we're looking at these hackathons, like what to build, ultimately, we want new ideas from you as hackers and participants in the hackathons. But these are some things that I think are kind of cool. We've seen there's a lot of decentralized gaming and bringing Bitcoin into decentralized gaming. Telegram is kind of a cool platform that we've seen a lot. The creator economy and monetizing market space and content creation is another cool theme. Memes on Bitcoin is kind of new. As of, I'm not sure how familiar you guys are, but earlier this year during the halving, a new standard called Runes was brought and launched, and that brought basically meme tokens to Bitcoin. And so bringing that into a network that's closely aligned with Bitcoin is key. Rootstock is a good home for that. Other things, on-chain governance, DAO automation, treasury automation would be really interesting to see. And then, fundamentally, the bottom one is probably I think the biggest opportunity in general to crack, maybe, more complicated, but, how do you bring more opportunities for tapping that Bitcoin liquidity through lending and borrowing protocols and models there? And from the ecosystem, you can see some of the partners. I think from the hackathon perspective here, some of the most interesting things are on the developer tools block here. We have compatibility with basically all EVM development platforms, so Foundry, Hardhat, those types of platforms, along with third-party platforms that you see here, ThirdWeb, Alchemy, Covalent. Sebastian, after this, is going to give a quick demo on using Alchemy. I think maybe they're so recently added, we didn't even get their logo on this, but yeah. And then, yeah, so the dev tools and libraries. So, if you've built on EVM, you've probably seen some of these before. But we also have a team on site here, and please come, ask us if there's something you're looking to do, you're not familiar with how you could use these tools, come talk to us, and we're happy to work with you. And then, yeah, why build on Rootstock? So in addition to the hackathon, like these are the things you can look at, post-hackathon. We have grants, so if you want to take your project forward, we have a grant program ongoing, and so you can submit your project and apply for the grants in here. And for this hackathon here, we have a couple tracks here. One is, looking at the best DeFi dApp on Rootstock with a $5,000 prize, and we also have you guys can scan up here later a Best Developer Feedback Award. You can also win some AirPods too. So we also have Best Use of the Rootstock blockchain. So two prize tracks here. And then the other reason or opportunity we have post-hackathon is what we call the Hacktivator. And really this is looking at the question of like, all right, I started with Rootstock, it's kind of cool, I like it, maybe I want to take this project forward, maybe I want to do something else, but bringing you into the ecosystem, providing support and things like that. So we have a content contributor program as part of this, so this can be submitting PRs to open source repos that we have these smaller types of lifts into what will eventually turn into more of an accelerated type program later this year. But yeah, come engage with us. We want to support the projects and teams building within Rootstock. And yeah, so that was kind of the Hacktivator. And so Sebastian's going to give us a demo here on the Alchemy. So this is one of the multiple tools we have for building your projects. He's going to walk you through the dashboard, how you get the RPC node and how to find and use that URL in one of our starter kits. So yeah, so we have all these QR codes in the presentation. Come find us if you need any help on it, but I'll throw it to Sebastian.
Hello, everyone. These are the demos that we will use. In this case, we will go through very easy tutorials that we have in our developer page. So you will have a front-end demo, which is a very easy-to-go tool for implementing a very easy and fast wallet connection with Rootstock. Also, we have a Hardhat demo, which can be also easily used for deploying and verifying your smart contract in case you need, right? So first of all, I would like to ask how many of you are hackers and are familiar with Solidity? And which ones are familiar with front-end integration and all that stuff? Okay, very nice. So you will find this at the end, or if you want later, go to our stand and we can share these links for you. Are very easy to go. So the first one we will check is the Hardhat starter kit. But lastly, we had a partnership with, let me search here, sorry. As Lansen said, we have a recently partnership with Alchemy. So we are now included into their RPC API services. So you can find easily this tool, which is very important in order to interact with the blockchain, right? You can just create your RPC API in very few minutes, and you can use that for interacting with the blockchain. We will see this in a moment. The only way you have to do is create your dApp here and go to the networks, and depending on the test, on the network that you will use, you can just pick which one you need, right? So you just copy. In this case, we will be working in 2 different GitHub repositories, as I told you before. The first one is this. Let me put this bigger. Is the Hard Hat Starter Kit. You will find here some examples of smart contracts that you can just deploy in very few minutes. We have some common standards like 721 or ERC20. And let me show the example. In this case, for matters of time, I have already cloned this repository in my computer. So when you start interacting with it, you can run different command lines that make it easy to interact with it, right? So, for example, if you use this one, which is a hard hat command, will help you deploy any smart contract that you have. In this case, we are deploying an ERC20 standard in a very fast way. If you go to the code, when you check it, you will find some deploy examples where you will see some of the parameters of the constructor or any configuration you need to do for this, right? So in this case, we will just deploy an ERC20 smart contract in rootstock testnet. For that, what I did was I took the RPC API from Alchemy for testnet and pasted it here for my on my end file. So Hard Hat will take this RPC URL in order to deploy the smart contract to the blockchain, right? So whenever you put it here, you also need your private key. Don't worry, this is a Bornet one, so no rush. You will need this information in order to be able to deploy this smart contract and verify, right? So it's as easy as you copy or paste this command, and you will be deploying your smart contract. After this, you can just run another command in order to verify the smart contract. In this case, as this contract is an ERC20, you need to indicate the command line interface, which network do you need to deploy on, which is the address of the smart contract you need to verify, which are the parameters for the constructor that you use to deploy the smart contract in order to verify. You know, if you have done this before, this kind of painful step in the smart contract development, the way to verify a smart contract, right? So this tools makes very easy to do this, right? So in this case, you just run the command, and in this case, as this was already verified, you can just interact with it. This is the first example. You will find all the information in the Hard Hat config. In this case, we used for verification. This is a very important part of the tool, the API URL that is used for verification. You know, normally that is the point where it becomes very hard to interact with these kind of verifications. So we use a tool from Block Scout to do this kind of verifications, which makes it very easy to go and follow. So when you have already your smart contract deployed and verified, the next step that you need to go through is the front-end integration, right? There is a tool that I love to use, which is named Rainbow Kit. I don't know if you are familiar with this tool. It's a very interesting tool because this one gives you a really big abstraction of how do you communicate your front end with your wallet, right? So this gives you some very nice buttons like this one and provides you this service. So in the example I was showing here before, we have another public repository called rootstock Rainbow Kit, which is already completed with this example. So you can just check is public, take in account that we have one branch called main and another branch called completed. So in the completed one, you will find the complete exercise. For matters of time, in this exercise, I will just show you the completed example, in which a very important point here is how you configure your network to be working with your front end, right? So in the main file of your DApp, you will find that this is wrapped into a WACMI provider, right? And this one has a config file. Inside of this config file, you will find the general configuration for WACMI and Rainbow Kit in order to know, hey, which network will you use to connect your DApp. So in here, by using the WACMI chains library, you can find your networks, any network you need. For example, if you use rootstock, this will be the mainnet, and rootstock testnet will be the one that we will use for connecting to the testnet, right? This is an important point. Let me show the application running. 1 second. This is the DApp. So this is a very basic example of how interact with your smart contract after deployment. The basic thing is how to read and how to write information to your smart contract, right? That is the point where every developer starts checking in these kind of hackathons. So we have those two functions, and in this example, I try to show two different ways to interact with this kind of functions. One is a called hook for React. I will go there in a moment, but I will tell you what are the most important points for this interaction in this case. The first one is the contract ABI. You know, for each interaction that you will need to do with your smart contract, the frontend needs to know what are you calling and what is the name of the function, what are the parameters that you need to call. So in here, you will find that we are using two different functions. The balance of, which is the one to read this and retrieve the balance of the user. And the other one is the function mint, right? Which will be minting tokens to that smart contract to the user. Other important thing that we have hard-coded here, but normally you will put this dynamically in some config file or in your .env file, is the contract address where you deployed your smart contract. And inside of this part, as I told you before, we have two different functions. One is handle retrieve, which is the one that we use for read the information on the smart contract. This function uses the read contract configuration from one package called WACMI core. With this one, what you does is call an async function called read contract, pass some parameters for configuration. In this case, I pass the address of the contract, the arguments, and the name of the function you want to call. In this function, you just receive async the value that you are retrieving from the blockchain, right? But for the write contract, let me do an example here. I will just paste it. Let's mint another 100,000. In this case, I have this hash. I just will check the status of this one. It's pending. So in the meantime, I can show you. This one is another example of how to use these tools. It's write contract. This is a hook from WACMI, and this is a reactive function. You just call the function write contract, and it's reading the status of that hook. So in any moment, the data, which we are calling here hash, changes, you will receive a change immediately in that state. So you are not receiving like in reading the value right there, but you can use this variable just in your code. In this case, as we use it here, as soon as the variable change, it appear here in the function. So if you retrieve the balance again, you will have 5, and you have add your balance to your address. So this is a very basic example of how to interact, and you can just go to these repositories and use them, or just ask us if you need. Okay? Any question? Yes?
So, kind of generally with Rootstock, do you use the same key system as Bitcoin, or is it separate?
No, it's separate. We are a sidechain on Bitcoin, so everything is EVM. So you can just create your wallets as you do in Ethereum with MetaMask or other provider, and it's just the same, but are not the same accounts that in Bitcoin. You can bridge your Bitcoin from Bitcoin to Rootstock because it's a paired token. Oh, sorry. The question was if if the wallets, if the accounts work the same, if it's the same account from Bitcoin in Rootstock, right? Yes, that was the question. Sorry, I forgot that. Any other question? No? Thanks so much. Hope you, if you have any questions, you can just go there, ask us. You can scan this code if you are working on this. You can go for these AirPods, or you can go for 500 that we have for the price track, which is very interesting for the best feedback that we can have in the hackathon. Thanks so much.
Thank you everyone for joining. I'm Sukanya, Senior Integration Engineer from Neon EVM. Today we are going to showcase how you can access Solana using Neon EVM, using your own Solidity smart contracts without writing anything in Rust. So first of all, let's just get to know what Neon EVM is. So Neon EVM is basically a smart contract on Solana. In Solana, the smart contracts are called programs. So Neon EVM is a program on Solana which can execute EVM bytecodes inside Solana's virtual machine. So we are basically not a layer 2 or not a bridge. We are just inside Solana's virtual machine. And Solana can have like executable files up to 10 MB. And like EVM is, I think, around like 2 MB or something like that. So it can embed the whole EVM into it. That's how like Neon EVM is. And with Neon EVM, like you can have all the benefits from the EVM ecosystem, like all the Ethereum tooling, which is already there. You can have like all the Ethereum tools for the development, like Hard Hat, Foundry, Remix, and also like you can use the already existing wallets like MetaMask, and we also have integrated Trust Wallet. And also like we have all the RPC methods available, which are already in Ethereum. So you can also use all of them. Those are all compatible with Neon EVM. Also, like you can get the benefits from Solana, which is basically the low gas fees, high transaction speed, and the most important thing is the parallel execution. So we were live since last July 2023. We have like all these components of Neon EVM. So this is EVM, which is basically the Neon EVM program. Then we have the proxy server, which is the main integral part of the like the transaction that happens, because proxy server is the thing which like gets the Ethereum like transactions, does a simulation, and converts it into a Solana like transactions, and then pushes it to the Neon EVM program. Then we have the Tracer API for debugging. Then we have Neon Pass, which is our native bridge from like Neon EVM to Solana and vice versa. Then we have Neon Faucet for the development. You can get Neon DevNet tokens from there. Then we have the Neon DAO, which is the owner of the Neon EVM program. Then in theory, like we can like go up to 2000 TPS, and like the transaction fees, like you can already see, like it's like very low. Yeah. So this is basically the ecosystem. We have all the wallets like MetaMask, Ledger, we have integrated. Then we have Trust Wallet, Gnosis Safe. Operators, we have 2 operators, P2P and Everstake. Then we have Explorers, Block Scout, and Neon Scan. Indexes, Graph, Subsquid. We have Oracle's Chainlink, Pith. Then we have the NFT tool, which is from Solana, which is Metaplex. Then we have our own bridge, native bridge, that is Neon Pass. And we also have dBridge integrated with us. We have a lot of DeFi protocols already deployed on Neon since last we launched in the July last year. So we have lending borrowing protocols like LendOS, Lumen, and we have a lot of other DeFi protocols as well. Like you can see on the board, like it's Ice Cream Swap, like Uniswap V2 fork on Neon. We have Vibrant Finance, Mora Swap, Lever Finance, and lots more. Then we have also like a lot of NFT and gaming platforms right now already deployed. You can see all the list there, that Versus X, there is Battle Dogs Arena, and like some more. And we have Launchpads, which is Minpad and Pixelrium, which are in deployment stage. And so we have all the developer frameworks, which are already available, Hard Hat, Foundry, Truffle, everything which is compatible with Ethereum, and all the SDKs and APIs as well. So, yep. These are the development tooling, already known development tooling in the EVM ecosystem. This is basically the Neon EVM architecture. So whenever like you have a front-end dApp, which is using a MetaMask wallet to sign transactions, you can have a Ethereum-like transaction then it goes to the proxy, which is inside of our operators who runs the proxies. The proxy basically provides an Ethereum RPC API to connect to it, and then it interacts with Solana to just convert the Ethereum-like transaction, does a simulation, and then it converts it into a Solana-like transaction, and then sends it into the Solana's virtual machine, inside of which our Neon EVM program is there, which can execute the bytecodes. So this is how like the Neon EVM architecture looks like. So basically, Neon EVM program, just to let you guys know how like a Solana's architecture is, because Solana is a little bit different than Ethereum. It can't store, the programs can't store any data, so they are stateless. So everything is stored in accounts. So you can see like the Neon EVM, which is basically a program, which is an executable program. It has a Neon account, which is like you can have a Neon account like your Ethereum account, which can store which is a program derived address, like from the Neon EVM program. It is a derived address for your Neon wallet, and it can store the data. Like the program itself cannot store data. So Solana is stateless. So this is how like it works. So this is the basic knowledge about how accounts are created and stored in Solana. So this is how a transaction goes through. This is how a transaction is packed into a Solana-like transaction. So you can see that the Solana transaction is a completely different one. You need to have the account list, and that account list is basically the list of all the accounts like you need to access when you are executing a transaction. Like you have an Ethereum transaction, and that transaction can access different accounts, like different data accounts in a same transaction. So you have to have that account list in the Solana transaction inside the proxy. And this is how like whole Solana transaction looks like. You can see like you have the address of the Neon EVM program, then the list of Neon accounts, contracts, and the data accounts into the account list. Then you have the index of the Neon EVM program into the program index. And all the Ethereum-like transaction data, which are the nonce, gas price, and value and the data, everything goes into the data field. This is the parallel execution, which is basically of Solana's main like feature. So Solana can execute transactions in parallel. So this is basically we are today, like before going into the bounties or talking about how to access the Solana into like going through the tutorial, we just want to like get you guys know like what the composability feature of Solana is. So basically Solana has the feature of like you can call like from a program, from a like Solana program, you can call another Solana program. So this is called the composability feature, which also has the cross-program invocation, which is basically like invoking instructions of a different program from another one. So this is how like our bounties are also today about. Like we are looking for like some kind of projects which are surrounding this composability feature. So it actually happens like the Neon EVM, you have a Neon EVM address, and you will have a Solana interface contract on like in Solidity, which can call an already existing precompile inside Solana's virtual machine. And that precompile has all the like the required functions which you need to call from the Solidity contract. So you can have the interface, and from that interface you can just call those methods. So this is how like it looks like. So we have the iCall Solana Sol contract, from which you can call the precompile, which already exists on SVM. So yeah, so these are like some of the bridges we have, like Neon Pass and dBridge and some other EVM chains. And yeah, just before going into the tutorial, I just want to like give you an insight of our incoming features, which are the multi-gas payment feature. Like we are experimenting with it, and most probably we'll be launching it soon with the multi-gas. Like you can pay right now when you do a transaction, you can pay only in the native token Neon, but we are experimenting with it, and we are trying to like do multi-gas payments. Like you can make payment with Sol, you can make payment with any other ERC20 tokens. So yeah, let's go to the tutorial first and just check it out how to access Solana. You can get the RPCs from just chainlist.org. Type Neon EVM and you can get the Neon EVM mainnet and Neon EVM devnet chains from there. Then, okay. Yep. So just as I mentioned already about the composability feature, so from Solana you can access Solana's from Neon EVM you can access Solana's liquidity. So you can from your smart contract on Solana on Neon EVM you can just do a kind of swap on any dexes which are already existing on Solana. Like you can do a swap on Orca, you can do a swap on Radium or Jupiter. So I'm just going to show you guys like how this works on Neon EVM, how you can access from Solidity contract, you can do a swap on Solana's dexes. As I have already mentioned about the I call Solana interface contract. So this is how the interface contract looks like. So we have like the instruction struct and the account meta struct, which is basically used when we are building an instruction that is passed to the Solana's transactions. So this is how the struct looks like. Then we have like the following functions. The Neon address, you can just pass any Ethereum Neon address which is there and just get the Solana address from that. Then we have some useful methods like execute and batch execute and then execute with seed. So these functions are necessary when we are executing transactions, when we are passing the transactions to Solana. So we will have to use these execute functions where we are passing the instruction and lamports. Lamports is the smallest unit of Sol on Solana. So these lamports are used when we have to have a pair for a transaction. So all the transactions doesn't need signing, but some of the transactions need signing. So for that signing purpose, we have to have some lamports for the pair. So this is how like we pass the lamports to the execute function. So here we have a config file. Like these tutorials are already available in our docs website. So you can go and just check it out there. We have a GitHub tutorial as well. You will find all the links there and you can just build like whatever like you can with that. So you will find all those stuff. But yeah, just to let you know that we have a config file here where we have already written all the useful functions that will be useful for doing a swap on Orca, Radium, or Jupiter. So it's already written there. So there are some of the functions like the execute or like the prepare instruction accounts, like how to prepare all the instructions for the Solana transaction to happen. Then we have this contract which is basically the contract which has all the functions for like a swap on Orca, for a swap on Jupiter, and a swap on Radium. So I have this function already which can be called through our script, which I will run in a few minutes. So this is a script which is batching two transactions. One is a swap on Orca and one is a swap on Radium. So I can just run it and show it to you guys. So Radium and Radium has a doesn't have a dev environment, so that's why we need to do it on mainnet. So I'll just run the script. I think something is not Just a moment. Yeah, I think there is. Yep. Yeah, now we can see, we'll be able to see how the transactions is broadcasted to Solana from Neon EVM. It may take a little bit of time, guys, because mainnet sometimes like it takes a little bit of time, but yeah. Yep, you can see that the approval of Rapsol. So this is a script where we are swapping Rapsol with USDC on Orca and Radium both together. Yeah. Sometimes querying the Radium pools take a little bit of time. So I can just show you guys one more transaction till it happens so that we have this. Yep. So this was a transaction that was done last night. So this is basically a Rapsol to USDC swap on Neon EVM. You can see there are 7 transactions. We have like 7 Solana transactions. So why this is split up? Because the Neon EVM transactions sometimes are big enough, and it cannot fit into one Solana transaction at a time. So that's why like the proxy, it splits the transaction into smaller transactions so that Solana can fit into it, and it just does the iterations like that. If you can click on the last transaction, you can just see that we had an interaction with the Neon EVM program, and you can see the swap happening on Radium and a swap happening on Orca as well. So in the last transaction, you will get all the aggregated data of all the transactions. So this is how it happens. And yeah. So let's see if it has gone through. No, I think Radium is still taking time. But yeah, it's fine. I think I can just show you the Jupiter one then very quick. Yeah, Jupiter should go on real quick. Sometimes Radium pools data, like it takes a lot of time to process. So yeah. So with this script, this is a Jupiter swap script. So here we are swapping USDC and USDT. I already have a transaction happening like this. So this is another transaction which happened 3 days back on Jupiter from Neon EVM. This is a swap from USDC to USDT. It's the same thing. We have 3 Solana transactions split into like 1 Neon transaction split into 3 Solana transactions. And the last transaction can give you the details that it is interacted with Neon EVM program and the swap happened on the Jupiter. So let's see if it has gone through. I think no, because it's mainnet, so it takes a little bit of time, guys. Yep. Let's see our bounties then for now, like just to let you guys know. Yeah, so these are our bounties for regarding the composability. So, yeah. You can just build anything surrounding composability feature, like if you can have like any cross-chain DeFi aggregator or real farming, which you can like deploy on Neon EVM and then access it on Solana, like using the composability feature. Anything you guys can do with it. And we also have a bounty about developer toolkit or SDK libraries that will be easily that will be easy for developers to get access to Solana. So these are our 2 bounties for this hackathon. So yeah, just go through it, guys, and I hope you build something good on Neon EVM. Yeah, I don't know like why this mainnet is not working, but yeah, I think it's worked. It worked. Yeah. So I can just show you a little quick. Okay. Yeah. Okay. Thank you so much. Thank you so much, guys. Yep. Yeah, sure.
You show the execute function. You have any function which is meant for viewing the state rather than executing something on Solana?
I didn't get your question. Yeah.
Yeah. So, do you have any other function other than execute which
Mm-hmm.
allows you to view the Solana state rather than executing something on Solana?
No, I think we don't have like that function because these functions are already in our pre-compile, and I don't think so we can get a state from Solana.
We have another precompile which is called read Solana, which actually you can read any account data. This is how we actually read price feeds, basically Solana Chelly price feed, big price feeds. We read directly from Solana, so you can read any data from Solana. You can read it through our precompile.
Yeah.
So we have a precompile to execute. We have precompiles to read.
To read, yep. Mm. Okay. Thank you.
Testing. Cool. Hey, everyone. I'm going to get started talking about declarative blockchains and what we're building at Essential and how you can build on us. So a sort of quick caveat as to what we've got going on today. Unfortunately, none of our devs were actually able to make it due to some visa issues and some other scheduling stuff. So I recommend everyone check out the Pint workshop. QR code's there, otherwise just on the ETHGlobal YouTube channel. That'll give you a sort of live coding workshop that details how to set it up and all of that stuff. And then, there's only a handful of us, but when it gets to the questions component, I'm happy to answer questions about the overall model and the declarative architecture, but more technical questions about the language and all of that stuff, we can direct you to our devs on Discord and have a back and forth there. So yeah, okay. Basically, let's start out just introducing the declarative and imperative programming paradigms to understand, what it is that we're actually building at Essential and how you can build on us. So in computer science, obviously, I'm sure most of you are devs, so you'll know the basics of these two paradigms. Basically, imperative programming paradigms describe how a problem should be solved using explicit instructions. So the developer outlines instructions in sort of an algorithmic step-by-step execution format, and the priority is to follow the instructions regardless of the outcome. Then declarative programming, on the other hand, expresses what a program should accomplish rather than how. So the developer specifies the desired outcome without dictating how to achieve it, and ultimately the valid outcome is prioritized over the instructions. So you can think of some imperative languages like Java and C++. I'm sure you probably already know. Declarative languages include like SQL, Haskell, and of course what we're building at Essential with our declarative DSL called Pint. Okay, so the current state of blockchains is that they're basically all imperative, at least since the advent of Ethereum as like a general purpose smart contract blockchain. The imperative model has been the prevailing paradigm in blockchain development. And what this means in practice is that users and smart contract developers interact with the blockchain and update state via executing instructions, i.e. imperative, rather than declaring their desired outcomes in a declarative way. So most of you have probably heard of the vending machine analogy for smart contracts. The idea is that it's basically a simple self-enforcing contract and that it should enable automatic execution and remove the need for trusted intermediaries. So Ethereum says that the benefit of smart contracts is that they deterministically execute unambiguous code when certain conditions are met. And they don't need to wait for some sort of agent to interpret or negotiate the result. But this kind of masks the fact that imperative smart contracts, while they have unambiguous code execution, actually leave a huge amount of room for ambiguity when it comes to what end state you end up getting. And so to understand why, let's look at the current state of smart contract interactions using this metaphor a little bit more deeply. So say you go up to a vending machine and you know that you want to buy a bag of Doritos. So you walk over, you have to select whatever slot the Doritos are in, let's say it's A2, and then you insert your money. So at this point, this is the equivalent of having initiated a transaction on an imperative blockchain. But then, while you're waiting for your order to be processed, someone comes around the back, switches out all of the stock in the vending machine, and all of a sudden there's no more Doritos, and you're left with a machine full of Coca-Cola or whatever else, something that you didn't want. And so what's happened here is that this person has been able to change the state of the vending machine after you submitted your transaction, but before it has actually been executed. And so then when these instructions that you entered finally are executed, you don't end up getting what you wanted, but the crucial thing to note is that you actually do get what you asked for, because under this model, it's not possible to ask for a bag of Doritos. The system doesn't have an internal conception of what that is. So the best you can do is say, give me the item in slot A2 and hope that the state of the chain matches what you anticipated when the transaction is executed. And this is because the imperative blockchain state machine system has this concept of an intermediate state between block A and block B, the space in which transactions are being executed, and the state can change and be manipulated, and things can happen during this intermediate state. So people, I'm sure, will all know this as the dark forest, as it's called in the Ethereum world. And basically, it was originally an unintended side effect of imperative blockchain designs, but there's a lot of people today who make money exploiting this dynamic, and for them, it's not really a bug, it's more of a feature. So there's actually an entire industry that's dedicated to tinkering with the vending machine in order to extract value from these unsuspecting end users, and that is what is known as MEV or the dark forest or any of these kinds of things. And so basically the philosophy we take at Essential is that we don't think it should be possible to do this. And even the Ethereum yellow paper states that users should be able to interact with the system with absolute confidence in the possible outcomes. That's not something that's currently possible today. And that word outcomes obviously brings us back to the declarative model. And that sort of philosophy is what gave us ideas around how to build this into a blockchain. So if this imperative paradigm is so limiting and users and developers and networks are all struggling because of it, then why hasn't a different approach been used? Well, actually, people have been talking about using declarative approaches to smart contract developing since as early as 2018. Influential members of the community have proposed this as an alternative. But even though it's been discussed over the years, it's only really started to gain traction in early 2023 when the concept of intents came about in the blockchain space and really started to get attention. So projects like CowSwap, Uniswap X, 1inch Fusion, you might have heard of some of those, are sort of have been bringing the intent philosophy into the forefront. And the core principle of intents is that they allow users to sign over their intended interaction in terms of outcomes, which is declarative, rather than in terms of instructions or transactions, which is the imperative model. But the way that most of these projects actually implement this is that at some point during the transaction supply chain, it still turns the outcomes that the user has expressed back into instructions that need to be settled. So because they're still using imperative state machines like the EVM or SVM or really any other state machine to achieve settlement, that means that ultimately at some point a solver needs to come in and turn this user's expressed outcome back into a transaction. So basically this is still like the vending machine model but just with extra steps. They let you to just get somebody else, like a solver, to interact with the vending machine on your behalf. But ultimately this risk of losses and like unintended consequences that comes from the imperative model and the dark forest still exists. It's just about whether the risk has been passed on to some other party. So people are building solutions that make the solver take accountability for the result they deliver, rather than have the user take accountability if the outcome doesn't actually reflect what they expressed. But ultimately, it's still passing the fundamental issue onto someone else and not actually reducing the amount of extraction. So we propose just getting rid of the vending machine. If we can't defend it against the people who want to exploit it and its users, despite many, many efforts to reduce or mitigate MEV, then what can we do instead? Well, now that we have all of these intent projects and solver networks spinning up, we have these agents that are ready to come and step in and execute contracts on behalf of users rather than have them be always self-enforcing. So we propose using them to directly fulfill users' intents. And so with this, we propose the idea of a declarative blockchain. So these are blockchains that leverage constraints to achieve state updates without the need for execution. So there's a few kind of important things in here. The constraint component is closely tied with declarative programming, where interactions or intents are expressed in the form of constraints on state. And then because we're able to directly constrain state, execution can actually be removed from the blockchain or transaction supply chain entirely, because you're able to just directly update from state A to state B without having computation along the way. So this means that, not only is there no on-chain execution, but actually no in-protocol conception of execution at all. So basically, to go a little bit deeper, the entire flow in this system is declarative from beginning to end. So the first step is the intent, user interactions. So they submit their intent in the form of constraints on state, meaning that basically users can ask for exactly what they want in terms of outcomes, and the user experience or the flow on the front end is actually similar to the current model, because what users do right now is just click some buttons and say, this is what I want. But what they're doing when they actually sign over these inputs is that they're signing over their intent in the form of enforceable rules, constraints on state, rather than just a set of instructions to be executed. The next step is that smart contracts in the system are also declarative. They are built in Essential with our DSL called Pint for programmable intents. And basically, these also consist purely of constraints on state. So instead of outlining these specific instructions to be executed, they just outline the rules that govern what can be considered a valid new state. And then any intent that interacts with them just has to fulfill those rules and meet all the constraints. And then finally, the state machine itself is fully declarative. So basically, when users submit intents, solvers are then waiting to ingest those, search for solutions off-chain. So there's a computation component, but that doesn't have to happen in protocol. And then these solvers can directly propose their solutions in the form of state updates. So there's no need for any execution VM, just a constraint checking VM. So what happens on chain is not actually the computation of how to progress state, but just that new state is proposed, and then the on-chain component is just checking that all of the constraints have been met. This is obviously a lot more lightweight than doing all of the execution in an on-chain and redundant environment, and moves all of the sort of more heavy computation off-chain. So this looks more like a true distributed ledger. When you think about what you want out of a ledger, it's just a record of the current state of the system, but doesn't necessarily have to contain inside it the logic for how to update the ledger. So by moving all of that stuff off-chain, we achieve a bunch of efficiency and make it also a lot easier from a smart contract development perspective as well. Okay, so getting a little bit more specific about Essential, we're building an Ethereum layer 2. It's not based on any particular VM or existing stack. Rather, we're building a completely new VM from the ground up that is purely just based on this constraint checking philosophy. But obviously, we will be interoperable with the rest of the blockchain ecosystem, other L2s, and posting blocks directly to L1 Ethereum. And so, yeah, to build applications in this environment, developers such as yourselves will be using Pint, which is our constraint-based domain-specific language for programmable intents. We've been building this for the past sort of a little over a year now. And yeah, it's basically designed specifically to interact with our constraint VM. And yeah, so what to build today? We're still relatively early stage at this point. We have a DevNet up, and we're just getting people to start exploring and building and understanding what do applications look like in the declarative paradigm, and what do smart contracts look like under this model. So we're mainly focusing on DeFi, so we're encouraging people to build really any early stage DeFi primitives, anything as simple as trying to optimize a token contract. We've already got some in our docs that you can check out, but figure out if you can build one that's better or more efficient than what we've got. Other things are like AMMs, lending protocols, name service. You can go with something pretty simple. Otherwise, interoperability is another really good one. And if you want to do something a little bit more complex, maybe an options protocol or an order book DEX would be really cool. And yeah, if you have an idea for something that's within the ecosystem, maybe it's interoperability or it's a solver thing, it doesn't necessarily use Pint, but or it's not built in Pint, but it's still sort of a tool for the ecosystem. Chat to us about it, because we'll let you know whether it sort of meets the prize criteria. But yeah, ultimately we're looking for people to build anything that they're inspired to build that helps build out the essential ecosystem. And yeah, our first prize is 8K and 2 runners up at 1K each. So yeah, that's really the only prize track that we're doing. And yeah, so like I said at the beginning, some of you might have missed it. This was a very high-level talk. We have a sort of Pint workshop and walkthrough on the ETHGlobal YouTube channel, so please feel free to check that out. And yeah, join our Discord. Links are up there, and from there you can chat to our devs, understand a little bit more. If you have any deeper questions around how the language works or what you might be able to build, or if you have any challenges with building, our people will be there to answer all of those. Yeah, that's it from me. Thanks, everyone. Yeah?
We see an example of Pint
Is there an example of Pint? Yeah, I can, take you back to the beginning here. Can I zoom in, is the question. No, let me, yeah, the question was just, is there an example of Pint? So let me see if I can bring it up. Oh, it doesn't seem to be coming up now. So I will. Yeah. If you go to the docs, I'll bring the slide back up there. There are plenty of examples of Pint in there, and a getting started guide as well. So the question is it EVM compatible? So currently it's not directly EVM compatible, so applications built in Pint will be deployed on Essential and will reason about state on Essential. And so if you have a Solidity application or anything else, at this stage it just requires a rewrite. There is a sort of future roadmap item where eventually we'll be able to ideally run the EVM on our chain itself in the constraint VM. But yeah, at this stage, that's a future thing.
Is that rewrite changing the addresses of the precompiled or rewrite from Solidity to Pint?
Yeah, so the application will need to be written in Pint, basically. But yeah, I encourage you to check out some of the examples, basically, because you don't have to actually go into all of the idiosyncrasies of how to interact with the execution VM. All you have to do is outline application logic. So it's actually a lot more simple, what you need to include in a smart contract. Because really it's just outlining the logic or the rules that need to be met in order for state to be updated.
Okay, two last questions. Do you have any scheme to control how fees are paid? Can I sponsor a fee or can I do a zero fee? That's one thing. The other question would be, is there a bridge between your EVM and other EVMs? You would go to talk some way to another smart contract written in Solidity, different.
Yeah, wait, so the first question was?
The
The
fees.
fees. Yeah, so there is a fee mechanism. Basically, the way it works is when solvers propose a solution, they'll be able to take a cut from the price that they're able to pull on chain. Let's say it's for a swap, and they are finding that liquidity for a user. As part of their solution, they're able to take a cut from that. And the question is, how much do they keep for themselves? How much do they end up passing back on to the user? But because solvers are all competing and the optimal solution for the user is the one that is the winning solution or will get selected, there's a sort of competitive market dynamic, almost like an auction in there, where solvers are incentivized to bid as much value back to the user as possible in order to prevent not being the winning solution.
So that's the user who read the transaction. He has to be the payer. If I'm making a transaction, I have to pay for it. I cannot have someone else paying for me. It has to be in the same transition, the transaction and the fee.
Oh, I see. No. No, you can also have sponsored fees. Yes.
Okay, thank you. And the second question would be, if there is a bridge between your EVM and other EVMs. So I can write something in Pint and have it talking through a bridge or something to another EVM.
Yeah, so our canonical bridge to the layer 1 Ethereum for the purposes of settling, for finality on the L1, will be able to communicate directly with Ethereum. Other interoperability solutions, we're talking to a bunch of chain abstraction protocols and bridging interop solutions. So right now we just have a DevNet up, and so any of that interop isn't currently live. But yeah, obviously we will be bridging to other all other layer 2s and non-EVM ecosystems as well.
But that network can talk to another test network. As of now.
Oh right, as of now, is there a yeah? So for this hackathon, no, there's no bridge between the DevNet and any other chains. Sorry, I was confused by the question. Cool. Thanks everyone. Yeah, happy to chat afterwards as well.
Yeah, I think I'm ready to start. Cool. Hey guys, I go by Sauce. I'm the protocol engineer at the Uniswap Foundation, and today's talk I was just going to do a simple just intro to Uniswap v4. I describe it as this rabbit hole because you'll see shortly about like all the intricacies of v4 and like what's possible on Uniswap v4. So in case you don't know, this is me on Twitter. I'm also known to be like the troll on GitHub as well. And so those are some of the funny moments on Uniswap v4. So quickly on like what Uniswap v4 is and like all the features of Uniswap v4, we have first is like the singleton design. So what that means is every pool is managed by a single contract. This is different than v2 and v3, where every pool or every trading pair existed as its own smart contract. And so if you wanted to trade across multiple pools, you're transferring tokens between every single pool. And with this sort of singleton design, you get what's called like flash accounting. I think Euler calls it deferred balance accounting, where essentially you can string together a bunch of complex operations like swap and add liquidity, swap across multiple pools, swap where you create like 2 or 3 different like token outputs, right? Like 1 token input, but like 3 different token outputs. And at the very end, you only have to do token transfers for the input and output tokens. And so that's kind of what flash accounting is. There's something called ERC 6909, where essentially instead of trading with ERC 20s, you could wrap them as 6909s, which are a little bit more gas efficient for like high frequency traders or like MEV bots. There's support for native ETH as well. So in v2 and v3, you had to wrap your Ether, but in v4, you can just trade using native Ether, so that's a really nice UX benefit. One new feature on v4 is donations. What donations are ways to send tokens to the contract, which then accrue to liquidity providers. And so this is just like an entirely new feature in v2 and v3, which allows you to do really interesting like value distribution mechanisms. In v4, we also have no fee tiers. In v2, it's at a fixed 0.3%. In Uniswap v3, there's like 4 or 5 different fixed values. In v4, it's like fully continuous. And then we also have dynamic fees, which is also very programmable, where you can like adjust fees up or down. The core protocol doesn't make any sort of like hard-coded decision on how the fees should be changing, and so that's kind of something for developers to look into. And then lastly, hooks, which is kind of like the bulk of where v4's flexibility comes into play, and that's where I'll be spending a lot of time. So all of these together kind of summarize v4 as being an extension of v3 with way more flexibility and gas efficiencies. Unichain. As you guys saw last week, we announced a DeFi-centric EVM equivalent L2 built on the superchain. So I figured I'd just like quickly chime in. It has 250 millisecond flash blocks, or like transactions confirmed super quickly. We have this validator network associated with it, and then also priority fee ordering / less sandwich attacks happening on Unichain. But back to v4 and hooks, we have, so what are hooks? Hooks are arbitrary solidity in the swap lifecycle. So what is the swap lifecycle? It's really the full end-to-end experience that you would see on Uniswap. So like creating a pool, adding liquidity to it or removing liquidity, swapping, and then in v4 we also have donate. And so what hooks are separate contracts where you can make an external call and run just custom logic before a swap happens or after a swap happens. So that's a quick little summary on hooks. This is what it kind of looks like, where you implement a contract to a certain interface standard, and then inside this function, you can really do whatever you want. As long as it's valid solidity and it runs, you can run any sort of logic you want before a swap happens or after a swap. I'll probably do a deeper dive soon, but just wanted to show the code here. Before we get into it though, it's kind of good to have some context on the difference between like a hook and a pool. They're kind of synonymous with each other. And so you can think of pools as independent, unique sets of liquidity positions, right? Pools have at most one hook contract, and then the hook contract implements these hook functions like before swap, after swap, and then you can mix and match, right? You're not forced to use every single hook. You're not forced to, if you use before swap, you can use after swap. It's kind of up to you. So that's a little bit more context. And to really highlight this point, so here's the code snippet or the interface for creating a pool. Critically, you can see that whenever you create a pool, you define like the pool key. And that's the pool. It's a unique set of liquidity positions. And what the pool key is it's the trading pair associated with it, the fees, this parameter called tick spacing, and then lastly, you can see hooks. And so every pool has one hook contract. The cool thing is one hook contract could service multiple pools, right? You can design a hook contract that services ETH USDC, ETH Tether, ETH BTC. You're not restricted that, this hook is tightly associated with this trading pair. And so back to like before swap and after swap, things that I wanted to call out with the interface is, so in before swap, you will always know which trading pair you're operating on. It's possible that your hook is specifically tailored for a stable pair, so like USDC and Tether, or your hook supports like, ETH and staked ETH. And so you can like discern different logic dependent on the pool. In after swap, you actually get the results of the swap. So you get both how many tokens were sent in and how many tokens were going to be sent out. And so you could run logic on that where, if you wanted to do like bonus rewards or collect fees on your hook proportional to the swap result, you could do that as well. I also won't really go into the liquidity side, but we do have hook functions here. They're separated out based on adding and removing liquidity. This was like a security implementation. So there's the liquidity hooks. Now on to like hook ideas. So this is kind of where the rabbit hole really opens up. So one thing you can do, like I said, is like dynamic fees and fee optimization. You can create like incentive structures where, if you observe gas to be really low, let's decrease the fee to like incentivize some volume. You could argue that it should be the other way around, where like if gas is really high, the markets are fluctuating a lot, and therefore like LPs might want to capture more fees. So there's fun things you can do around fees. Dan Robinson a couple months ago put out this really cool work called sandwich resistant AMM, where for a given direction, let's say you're trading ETH into USDC. So over the course of a block, normally in V2 and V3, as people are trading ETH into USDC, the price goes up, up, and up, right? Or I guess down. But with sandwich resistance, you kind of pin the price at the start of the block, and every single trade within that block fills at the same price. You can do things like automated liquidity management. So after swap, you could compound somebody's fees, like auto compound their fees. You could expand their positions. You could decrease, concentrate their positions. There's a lot of like fun little like liquidity management things you can do inside of a hook. We could do like rebasing tokens or support for rebasing tokens. So things like the Aave tokens, Lido staked Ether, you could support through a hook, either by sort of wrapping it as wrap staked Ether, or you can create like this custom pool that lets you essentially manage Lido staked Ether. So yeah, automated wrapping, and there's a feature in V4. It's quite advanced, but it's called custom curves, and it lets you sort of eject or circumvent the V3 swap math and sort of implement your entirely own custom curve. Another aspect related to custom curves, and this is kind of like a hot topic these days, is like application controlled execution. And the idea is like you could write logic inside your hook that controls actually the order of the sequencing of trades that are happening against this pool. So like, what if you introduced like a bidding mechanism and transactions are ordered based on a bid? Or you could somehow like prove the timestamp of a trade and, you know, order based on timestamp. And so there are some things you can do inside the hooks. As for more general V4 ideas, like, you know, our bounties and our prizes aren't really just hooks themselves. We have liquidity mining with subscribers. Subscribers are like a new feature in V4 that lets you do liquidity mining. So in V3, if somebody was saying like, oh, I'll pay you X amount of money to provide liquidity, what you would have to do is you would have to transfer your LP position to them, and that opens up a lot of like security risk. And so subscribers essentially let you do that without having to forfeit or like sacrifice your liquidity position. One thing that I haven't seen really is liquidity position oracles. So if you wanted to collateralize a liquidity position on like a lending protocol, you need a way to like price the value of the liquidity position. And so that's one project that you guys could work on. Like I said about ERC 6909, it's like this sort of token wrapper. And so if you could build like some sort of staking system for this token standard, that'd be pretty cool as well. Lastly, we also have like developer tooling. So things like maybe like back testing LP performance. Because like one of the things that we're super optimistic about at the foundation is like LP profitability, right? You can design hooks that increase LP profitability, but it's always good to like back that, right? Instead of just going out on Twitter and saying like, oh, this hook is amazing. So building tooling that can like verify and like back test a pool's performance, I think is pretty sweet. Testing kits, of course, are super useful. And then lastly, like indexing as well is also like a really great topic within V4. Cool. As for the prizes, we have 3 categories. The first one is hooks. Some ideas, like I mentioned, are like dynamic fees, custom curves for like stable pairs, RWAs, or very like nuanced and specific tokens. Like I guess the 2 categories of hooks that the foundation is super excited about are like, 1, anything related to LP profitability, and then 2 are like pools that are like specially tailored for certain types of asset classes. And so this is like stable pairs, RWAs, you could say meme coins as well. And there's an idea called like penalty hooks where, you know, with the custom accounting mechanism, you can kind of charge fees or charge penalties that if people are like misbehaving in your hook, like they're doing just-in-time liquidity, you can sort of penalize those. Our second category is this like catch-all categories that if you're, you know, building on Uniswap v4 but not directly building a hook, you could be eligible for a prize. So that's like liquidity management, developer tooling, MEV, LVR research, token issuance products are also really cool. And then our last category is like just deploying a DeFi app on Unichain. It doesn't have to be Uniswap specific. Any sort of DeFi app would be eligible for the last category. And so I go by SaucePoint. That's me on Twitter, Telegram, and GitHub. You can find docs on docs.uniswap. And then the Uniswap Foundation has this like starter template called V4 template that lets you get started on hook development super easily. And with that, I can open up the floor to questions. I know we do have a mic for the recording, so if you do have a question, feel free to go up to the mic. If you're uncomfortable with going up to the mic, you can just ask it and I'll repeat it for the crowd. So. Cool. If there are no questions, I guess we're all set here.
Okay, I think we have one person, and I'm really glad for you guys to be here. I go with Naruto as my anime name. It's just an anime that I loved. But today we're going to be talking about Avail 101, what Avail is, and what you're basically building, or what you can hit on bounties. So what to expect during this workshop. We're going to go through Avail Trinity, Avail DA, Nexus Fusion. There are 3 different products. And then from there, we're also going to, deep dive into the architecture of Avail and then some examples of what you can build with. So first of all, what is a DA layer? So everyone keeps on asking what's a DA layer, what they can do with it. Generally, Ethereum or any monolithic chain, they're divided into 4 layers with different tasks. So you have execution, settlement, consensus, and DA, which is the data availability. DA is basically where nodes can look at the data, and it's contained within all the blocks propagated through P2P network. The basic idea is that you want the data to be available all times, and then people can link through the nodes and look what there is, right? So nothing very super, complex. A data availability layer is basically where you post all the data, and then you make sure that data is available at all times. Big picture. So Ethereum has so many rollups. It's a L2 landscape, and at this point, there are more than I think 100 rollups coming in, and that's what we want to do. Because of all these things, you want to have these DA layers where these rollups can post data, because dank sharding or the 4844 is way too ahead. Full dank sharding 4844 is right there. What DA solutions do is that Avail DA is powered by erasure coding. KZG will go through all of these things, what they really mean, how you can actually do stuff with these, and then what is the fragmentation of liquidity and UX that you keep on seeing with L2s. I'll go with all the details, but this is the basic big picture on what we're trying to achieve here. We have a DA layer, and then from there we have Avail Nexus, which is what unifies the L2 or Web3 ecosystem. And then we have Avail Fusion for macroeconomic security. Avail unification layer. So these are 3 products: Avail DA, Avail Nexus, and Avail Fusion. What is Avail DA? Avail DA is basically a very powerful validity proof-based DA. What it basically means is that you have blob space that can help scale through the light clients, and then DAS or data availability sampling. There's an easy verifiability through KZG commitments. We'll also go through KZG, what they are, and when they came out to be. That was 2010. But Avail DA is on mainnet now. So we went mainnet three months back, and there's also a testnet that you can play with. Then there is Avail Nexus. So Nexus is pretty interesting. It's a permissionless verification hub. What basically it means is that think of a ZK coordination rollup where you have to do a lot of cross transactions, but you're trying to curb the fragmentation that happens through liquidity. So it uses proof aggregation. Proof aggregation is basically you generate multiple proofs for different rollups. So as you can see in the diagram, you have let's say rollup 1, 2, 3, 999, whatever, right? And all of these basically generate a proof, and then this proof is aggregated
and all these proofs get submitted by one single proof. So there's a lot of proofs happening, and then a single aggregated proof is what generates it. And then we use Avail DA, data availability layer, as a root of trust for everything here. It also has a sequencer selection, so all the transaction sequencing and inclusion is coordinated via the decentralized sequencer. So that's a different mechanism, and we're working on that. We're targeting end of 2024 for this, but right now we're going to focus on Avail DA because that's where your bounties lie. And then finally, Avail Fusion. It's a shared security layer. As I previously mentioned, that we also want to look into cryptoeconomic security of the ecosystem. So because of that, we are building Avail Fusion. Big thing about this is that it can also take multi-assets from different ecosystems like Bitcoin, ETH, for the additional security. So that's what it does, and it contributes to the consensus mechanism overall. I'll skip this, and then Avail DA. Okay. So as you can see, Avail DA is a modular base layer. What it does is that it gives you the block space to the modular chains. You can think of it as a sequencing, packaging, and publishing data, and then it can segregate text transaction data or like for any rollup, right? So Avail DA will have a lot of like validator set, and it uses something called nominated proof of stake for the consensus mechanism, where we'll go forward later on for this. And then finally, like each rollup, it can be built on Avail DA for any kind of like custom things as well. So you can have app-specific state machines. You can change multiple things in your rollup that you deploy on Arbitrum stack, OP stack, or zk-sync chains. Any questions so far? Good. Okay, so Avail DA Lite clients leverages KZG commitments. What KZG commitments basically mean, I'm gonna just go forward for a second, but KZG commitments are something that commits to the values of like, anything in a succinct manner. You generate very small proofs, which makes it easier for Lite clients to verify the availability. So think of this way: you have nodes, you have a different validator network of nodes, and then you have a Lite client. These Lite clients are very much capable of, instead of like just downloading the whole node, they can verify it without downloading the whole node or like whatever there is. So the idea, very small idea, is that there's a validated proof. It can be generated, computationally efficient to prove and verify the data is actually available and live. So that this means that you don't, as a dev or as a user, you don't need to like download the whole block space that was probably there since like 3 months, a year, or 2 years long. You can just verify through the Lite clients. Going back, we also use eraser coding and data availability sampling. So this allows, as I said previously, it allows the verification without downloading the whole block data. So there's a multiple things that happens in the back. And then this is the whole thing that allows for you to build anything on top of Avail DA, because you have Validiums, L3s, Optimums. You can use anything to build these things. And at the same time, there can be shared security because we have Avail Fusion. And then applications, they do not need to have their own validator set. There's a validator set that we have. So in very general terms, you have KZG commitments, you have erasure coding, and then you have data availability sampling. I went through the KZG commitments. What erasure coding is that it's basically a method for protecting your data. And then it has been used for CDs to protect the data. And what it generally does is that it adds the redundancy to the data and separate them into the chunks. As you can see in this whole diagram, that you have a data and then it gets, divided into multiple chunks. And then finally, you have data availability sampling. DAS is a very big thing that has been used by multiple projects. And what it does is that it leverages Lite clients, validated proof, and erasure coding to randomly sample data from Avail blockchain. And the bigger thing is that you can get 8 to 30 samples for the the random checking or the guarantees of the data. Okay, this is the architecture. It doesn't have, just for theoretical knowledge, it won't be for the bounties, but it's a good thing to know that how it generally happens is that you have an original data, you have an extended data that is generated with the erasure coding, and it generates Avail header or a block, and that's the KZG commitments. Now this KZG commitments is later on constructed as a block. You have a block which has a header and then data plus the extended data that came from before erasure coding. And now this block is propagated in the network of the nodes or validators. So every validator is gonna, decode it, reconstruct and verify. And then finally, it can reach consensus on the block. So this is a very base layer architecture of how the Avail actually works. Avail D actually works. And then, okay. Base layer stack, as I said, like there's also something that we very much focus on. It's consensus Babe plus Grandpa. So you have data availability, and what Babe is it's a block production engine optimized for liveness. At the same time, we also have Grandpa. This is another consensus algorithm, which is a finality gadget. The reason why we have Babe plus Grandpa is because we wanted to find a balance between data availability and we wanted to find a balance between the liveness, and we wanted to have something for finality as well. So finality not on the blocks, but it's on the chain. And then you can also have like different kinds of, there are other consensus algorithms as well, like Tendermint, but we chose specifically for Babe and Grandpa because of the a good balance between liveness and finality. This is also not related too much for the hackathon, but it's a good thing to know that you have a nominated proof of stake. Generally, there's also something called delegated proof of stake. We chose this mechanism because it is more decentralized, and this allows for the whole chain to not be halted if someone has a large stake in the pool and they get a large reward. So because of this, we chose something called nominated proof of stake. As you can see, nominators can choose not a single validator, but provides a ranked choice of validators. So there's a fair elections of active validators set based on a different kind of election. We support up to 1,000 validators in the active set. Right now, it's probably close to 100, but we can scale it up to 1,000. That's the big thing about the Avail DA and the nominated proof of stake. Light client networks. So this is one of the powerful tool that we have in Avail DA. What basically light client work is, it's an overlay P2P network on top of the base layer. What it does is that it samples the data from P2P, and then you do not need to download the whole node as I previously said. It just randomly takes in for verification purposes. Okay, what's the Avail ecosystem that will be built on Avail? So you can build anything that is sovereign rollups, validiums, optimistic chain, we call it optimums at this point. You can also do app-specific chains, and then general purpose chains. It's a joke that you can do L4, L5s, but generally L3s are the ones that are coming up too much lately. So yeah, you can build validiums with zk sync. You have Arbitrum stack. You have OP stack, and then you can build sovereign rollups as well. Okay, so this is just a general diagram of like how the validiums and optimistic chains work. There's an L2 validium you see in Ethereum, and then data is being posted to Avail, and then there's an Avail attestation bridge, and then that's posted to Ethereum. For L3 validiums, it's a little bit different. L3 validium basically settle on L2 rollups, and they post the data to Avail, and then Avail basically sends it to Avail attestation bridge, and then it goes to L2 rollups. We want to skip the sovereign rollup just for the sake, because we are low on time. I want to show you some ideas on what you can do with the Avail Explorer, what you can build on it. First, we want to go through the bounties. So bounties are basically, you have a custom app chain. You can build a custom app chain using any rollup SDK. So this means that you have Arbitrum Orbit, you have OP stack, you have Polygon CDK, you have zk sync stack. So you can use any of them, integrate the Avail DA, and once the Avail DA is integrated, you can build anything. There's also Stacker SDK, which is very powerful. It's a micro rollup SDK where you launch micro rollups, write your code in JavaScript, and you can build certain games. You can work on some DeFi projects. You can make an NFT project. And then you have Move VM, Fluent. We're not going to go too much into those, but like Polygon CDK, zkSync, Arbitrum Orbit, or OPStack works really fine. Building with a whale. This is a $3,000 pool price. Here you can use anything to go creative. You can use RISC-0 or SP1 to build some custom application on a zkVM. And then RISC-0 comes again. You can also do custom rollups using Avail DA. You can make liquid staking for Avail. They're already out there some. And then you can do a P2P address book, which is basically utilizing the Avail Lite clients. Another bounty is Best Code Tooling project. This is basically something that can work on the ecosystem or the tooling for Avail. This means that you have an efficiency calculator, you can build some kind of multi-chain or app chain explorers. For example, something which will work with different kind of ecosystems, so the different chains, developer toolkits, dashboards, and then zk bridge auto-claim functionality. So anything that that works for the Avail ecosystem and developer tooling, you can build something and you can hit this bounty. Final bounty for $1,000 is testing documentation. This is specifically for ETHSF builders. We wanted to give a chance for the builders or the devs to run our stack and see what they can build or what are the errors there, and then give us a feedback in a .md file or a GitHub repo. If you're hitting on another project's bounty, you can also include that .md file, just name it Avail docs feedback, and then add it onto the project and submit it. So there are multiple different documentation, which I'll go through right now, but you have Orbit, OP, zkSync, or you have Avail.js SDK, Go, or Rust, and then you can go through those. Any critical value, add feedback on the docs, that's also needed. So anything, you can hit any of these. You don't have to hit all of these, but just one or two. Okay, that was a quick idea on what Avail DA is. What I'm gonna do now is I'm gonna show you how the Explorer works. Okay, so this is explorer.avail and then accounts. Here I have a dev wallet account, I have a dev wallet 2, just simple names. But what basically you're doing is you're submitting data to the DA. How you submit a data to DA, this is a UI, but you can do it through the code base as well, but I'm just gonna show you how you can do it through the UI. You go on the developers, you go on extrinsics, and then now here, you see they're using my dev wallet too. It's on the sub wallet, so that is the wallet that Avail uses. You can also use other wallets as well, but just make sure that you're not using any EVM wallet, because Avail is not an EVM chain, it's a substrate chain. So substrate chain generally starts with a number 5 rather than 0x. Or the wallet address is on the substrate chain, sorry. So now we're gonna see how you can utilize some kind of data availability here. So if you see, there are multiple different things that you can look at. We select data availability. There's a create application key. We'll go through what an application key is, but generally you just do a submit data. And we can type anything here. So we'll just type hi ETHSF builders. And then you can just submit the transaction. As you see, there's an app ID. So this app ID can be anything, but it's basically something specifically for you. You can use 0 as well, but if you have your own app ID, let's say 2 or 3 or 7, every person can generate their own app ID, and every data that is posted there goes on it, and you can index it, all your data, through just that. You don't have to take all the block space or index all the block space that was submitted before. And now all you do is sign and submit. 1 sec. Okay, so I submitted it here, and it should go and hit somewhere here. We have this open, or maybe the internet is too bad. Okay, so the data got submitted, you get a notification like that, and after a small second or so, it gets into the recent events. This is basically a network explorer here. So now you can see that this was the dev wallet 2 from sub wallet, and then it got posted over here. I can look into more things like what it is or what it does. I can look into the balance that was withdrawn, the data that was submitted through on this data hash, and then I can look for, let's say, extrinsic success. So basically, I can play around multiple things here, but this is what the Explorer looks like. If you want to check some other Explorer, you also have Avail Turing, which is a subscan. So it's a second Explorer similar to the previous one, but it's a little bit looks nicer, or the UI is there. So you can do multiple things over here. Now I want to show you the example that we had. So this is Avail GitHub repo. You see there's an Avail.js, and then examples, and then we have node examples over here. So I'll just show you. For the Avail examples, you have like TypeScript examples. We also have it in Go. We also have in Rust. All you need to do is install the TS node, and we also have this Avail.js SDK, which is a wrapper of Polkadot SDK. So now, just a general thing that we recently did over here, we submitted a data from the data availability option. So how you do it is you can look into this code here, and here. So this file is basically the code base of how you submit a data. As you can see here, it takes an API over here. It takes an app ID, so you can choose 0 or you can choose your own. And then it takes for the options and the account. So whatever the account you feed into it, you need to provide a mnemonic. The only reason why we're not doing it because it will just show my seed address, my seed phrase. And then this line is probably one of the most important lines. Or these multiple lines, is that it calls in the API and then calls the data availability and then .submit data. This is what we were doing on the UI side. From the UI side, then you sign and send, and everything happens on how we perform this certain action. So this action in the code base looks like this, and probably this transaction call is one of the most important one. You can use anything to post, as I say, like change the hello world to something that has meaning to you, and that's how you are posting data to the Avail DA. You can do multiple things as well. For example, here, you wanna create an application ID. So you can create any kind of ID, let's say 89. I can do the same thing through the code base. Create application ID. So this is the code base where you actually create the application ID here. And it does api.txt data availability create application. So it's basically calling the function, and it's very easy to just write these lines. You want to make sure that there's some kind of error handling here, and then here, so your code base is just working fine. So these are the examples that we have. You can look here for any kind of TypeScript file that you want to look at. So there's a connect, estimating the transaction fee, how much it costs, and then there's a text transaction balance or transaction balance transfer. So these simple, let me just show you the transaction balance here. So here you're looking for the old balance that you had, and this is the transaction call, which is what takes the transaction from your wallet and sends it to different wallet. So the line from 30 to 39 is what does the whole thing. And these are the examples that you can hit to understand what's going on with the different. You can just test it out. And then finally, I want to just go quickly on how you can deploy Arbitrum Orbit with the Avail DA. You can deploy multiple things. In our documentation, we have for the OP stack, we have for Arbitrum, and for Validium, we have ZKVM for Polygon, and then ZK Sync or Madara. But you can choose any one of them. And how it generally happens, and because of the bad internet, I would just want to go through this line of codes. You just have a Docker here. Once the Docker is done, you want to git clone the Avail project Nitro contracts, and you want to build it at the end. You want to have a .env file, change those env files, and then copy paste this config for everything. There's a good explanation of what chain ID is, what the challenge period is, what is a stake token or base stake or owner. and then once you deploy it, all you need to do is yarn build forge, and then yarn run deploy ETHRollup. This will, just deploy the rollup, and you'll see something like done here. So this is a very, spinning up your own Arbitrum Arbitrum chain with the Avail DM. Let's see. Once this is done, and for people who are very much familiar with the with the Go or Rust, we also have examples over here. So you can go at Avail Go, and you can look at different, examples directory. So you can look at the Avail Go SDK. You basically need to, go through these things. You need to set up your speed, seed phrase. You need to go for your API, and you need to define your API app ID. And then there's similar thing for the Rust as well. So these are the basic things. We have 5 minutes left. Anyone has any questions so far? No questions? Okay. So again, what you can build with Avail DA, I'll just explain you a few more things so that everyone knows for the bounties, because there are a few new people. Bounties that you can make: Arbitrum Orbit or OP Stack, Polygon CDK, ZK Sync, Stacker SDK. You can use any of these to integrate Avail DA and launch your own app chain, building with Avail. So this is basically using RIS0, SP1, or building some kind of liquid staking, or doing a P2P address book. And then bounties for best code tooling. This is something that builds a developer-focused tool, which our developers can use it, or people on the Avail ecosystem, they can use it. This include dashboards, this include multi-chain explorers, this includes like cost calculators or efficient calculators or visualizers. And then finally, the documentation. If people over here want to test out the documentation, you can test out for Orbit, OP, just create a .md file, and then have some of these, put into your GitHub repo, and then also some screenshots out that it was finally running. What kind of feedback you give, that also helps us a lot. Some code was not running, some thing was broken, some links were broken, any kind of these things. These are the major things that you can hit for the bounties. Okay. Got the picture? Okay. Any questions so far? Okay. No questions. Thanks a lot. Hopefully I could explain you. If you have any more questions, you can come to the booth. I'll be there for until 1 a.m. or something. Okay.
right. Well, hello. I'm going to be talking about the Gnosis ecosystem and, of course, our bounties. So we have 3 different tracks today. The first one being build on Shutter on Gnosis chain. So there's a few different things you can do here. The main one being building a dApp that uses Shutter in some way. For example, you can use Nano Shutter that is like a local development environment so that you can very easily set everything up and use it to test, for example, commit and reveal scheme applications or anything that could use encryption and decryption in some way. But we would also very much like to have a dApp node package for the encrypting RPC, which is open source, of course, which would make it much easier to deploy. Or to integrate Shutter in a wallet, for example, using MetaMask snaps. Those would all be very great applications. Then we have build with circles on Gnosis chain. Again, of course, you can build betting and prediction markets. You can build social or voting platforms, custom groups and mint policies. Basically, just be creative. There's a lot you can do with circles. And, well, you should experiment and do fun stuff with it. You can also build a question application with Hashi. So you can use it to push your own data, basically normal bridging, or Hashi also publishes block headers on chain, so you can use those to build proofs, for example, and cross-chain applications in general. So there are 5 different prizes, at least, for those 3 bounties. All right, so I'm just going to be talking about Gnosis chain a bit, just to explain, because some people still don't know what it is. So basically, Gnosis chain is quite similar to Ethereum. So we have a beacon chain and an execution layer as well. We use the same clients, mostly Nethermind and Aragon, but Guest and Wrath are also coming. On the consensus layer side, you also use Lighthouse, Teku, Lodestar, and Nimbus, so basically the same clients. We go through the same hard forks as well, and we are arguably the second most decentralized network, well, available, I would say, with almost 300,000 validators today. So that's, yeah, a bit less than Ethereum, but still the second most decentralized network in our opinion, at least. Of course, there's also a few differences. So historically speaking, we were a proof of authority network based on Aura. So we never were a proof of work network. We use XDAI, which is so DAI basically bridged to Gnosis chain as the native token. So the gas price doesn't really is not influenced by the price of the token as it's a stablecoin, which is quite interesting, I think. But we still use GNO, so our ERC20 token for staking. And we have 5-second block times, which is 2.4 times faster, and 16 slots per epoch, so 2 times less than Ethereum, which makes finality twice as fast. We also have blobs, so we are, I think, currently the second chain, the only chain except for Ethereum that also has blobs. And we try to innovate on Gnosis chain with a plugin architecture, for example, Shutter being one of them. We also make the deliberate choice to say a layer 1 chain at Gnosis. I'm not going to go into too many details about this today, but mostly because we feel that layer 2s are still way too centralized, in our opinion. But yeah, this is some alpha, so this was, I think, announced yesterday for the first time. So we are hosting a debate about whether Gnosis chain should become a layer 2 at Dev Conflict. So that's an event we are organizing that Gnosis is organizing in Bangkok on November 9. I think this specific debate is with Vitalik and our co-founder Martin, co-founder and CEO. So you should definitely join if you are in Bangkok at that time. All right, so these are some informations about Gnosis chain. So basically RPC, chain ID, the explorers, a faucet, which we even have on mainnet. So if you want to try something out on mainnet directly, you can, free of charge. And documentation. So if you want, you can take a picture of this. But of course, all of this is also available on our documentation, so on docs.gnosischain.com. All right, moving on to the shutterized Gnosis chain. It's not the only thing Shutter does. And as a brief description, Shutter, well, its mission is to shield protocols and their users from malicious actors. So they mostly do this in two different ways, which is one by restoring privacy to voting protocols, for example, for Snapshot. So they secure that, well, voting basically on Snapshot. And by providing an encrypted mempool, which is what they are doing with us at Gnosis Chain. So yeah, we interrogate the Shutter encryption encrypted mempool. Sorry, and the way it works basically is that normally when you post a transaction, it's visible by anyone in the mempool, meaning that people can just take the transaction and then sandwich it or front run it or do whatever they want with it in order to extract value, which is otherwise called or known as MEV. So what Shutter does is basically you can sign your transaction and then encrypt it, post it on chain. Then it goes to a sequencer contract that basically defines in which order those transactions will get executed. As soon as a Shutter-enabled validator gets to propose a block, they get decryption keys from a set of decentralized keepers. They decrypt those transactions and then they have to put them at the very beginning of the block they are building in the order defined by the sequencer contract. And they are not allowed, of course, to add any other transactions in between. So they cannot front-run you, they cannot MEV you in any way because they have to respect that order and put them at the very beginning of the block. So this effectively makes those transactions private and impossible to MEV. So how can you use this? Actually, it was deployed in June, so you can already use it. And there's three main ways to use this. So either use the encrypting RPC solver. This is suboptimal because you still reveal your clear text transactions to the RPC provider, kind of like you would for Flashbots or MEV blocker. But the difference with those services is that for Shutter, that service is actually open source. So you can run it yourself, which is very important. Well, those are the two RPCs you can use on mainnet and Shadow. You can also use a wallet that already implements Shutter natively, but none of these exists quite yet. And you can encrypt transactions locally. So for example, directly in the dApp. So you would sign a transaction and encrypt it in the browser. But sadly, it's quite difficult currently, or no wallet actually makes it possible to sign a transaction without also broadcasting it. And if you're broadcasting it, then, well, you lose all the advantage of your transaction being private. There's just Brave Wallet that allows you to do that, but that's not sufficient to have good UX. So what do you come in? Well, basically it's to solve options 1 and 2. So the encrypting RPC, we wanted, well, if you are serious about privacy, you want to deploy it yourself. One easy way to do this would be to use dAppNode. So one of the bounty, or yeah, you would potentially win a bounty by developing a dAppNode package for this encrypting RPC. The second way would be to implement, well, Shutter directly in a wallet, for example, by forking a wallet or by using MetaMask snaps. Another way to come in or to use to win a Shutter bounty is to build a dApp that uses Shutter in a significant way. So for example, you can use it to build time locks or simultaneous move games. So for example, let's say you play rock, paper, scissors on chain and well, if you know what the other person played, then you can just win by default because you can choose the right move. And this can be prevented by Shutter. Or you can build blind donations or auctions, negotiation tools. Basically, that's a big set of applications that you could build with Shutter. Then we have Hashi. So Hashi is a robust and innovative EVM hash oracle aggregator. So basically, it's designed to enhance security of cross-chain applications. The way it works is that it reaches consensus basically between different oracles or bridges. So imagine that you want to, well, currently, for example, on Gnosis Chain, we have one bridge between Ethereum and Gnosis Chain that has many validators, but still there could be an issue in there somewhere. So what we want to do is actually have this set of validators like our custom bridge, but then also use a few different bridges and then make sure that they all reach the same conclusion. So for example, you could use 4 bridges, and if 3 of them agree, then you consider the bridge successful. So you no longer rely on a single point of failure. So basically it's additive security. You run the same thing with multiple different clients or bridges or oracles or whatever, and you make sure that in the end they mostly agree. So why should you use Hashi? Well, basically it's a flexible framework to build secure cross-chain applications that supports many chains, many oracles, and arbitrary message passing. So you can just publish any message and find it, or get it bridged to any of the other supported chains. And it also provides an abstraction layer for oracles. So basically you can implement any oracle and just use the same interface for all of them, so you don't have to write something specific for every different bridge or oracle. And if the one you want to use is not supported yet, well, you can just write an adapter yourself, deploy it, and then just use that as if you would use any of the other ones. This also makes it possible, for example, to swap out oracles or bridges in case one gets compromised or one is too expensive or you prefer a new one for whatever reason. You can just write a generic application and then at some point swap out the bridge you're using without anything, like without changing your code, basically. Hashi also does block header relaying. Basically what that means, it publishes the headers on chain, and then you can use that to verify state, basically. So to build proofs of any kind. That would then verify the entire chain of state of the blockchain instead of just passing messages around. All right, the next topic is circles, and I'm going to let Lucas present this to you.
Hi. So I will take a few minutes more to talk about Circles. Circles, it's a project developed by Gnosis Chain that represents social money for everyone. Circles, it's a DeFi protocol that let users mint their own tokens and exchange it with people that they trust. This project exists since already a few years ago, but it was a relaunch at 15 October, so last week it was relaunched within the Gnosis chain. We reworked the smart contracts and we also give addition with the SDK to help developers building application with the Circles protocol. So how does it works? First, you need to have a Circles avatar in order to be able to interact with Circles protocol. You need to get invited for this. So if you need an invitation, you can ask in the Telegram or in the Discord channel, or you can come to our booths to ask directly to us in person. And when you have the invitation, you will be able to create your personal avatar. When your personal avatar is set up, you will mint 24 Circles token per hour, per day, so 1 token per hours, and you need to trust someone in order to be able to exchange this token with him. So everyone has the option and is encouraged to trust others, because we encourage you to trust as many people as you can, because it's like this, you can benefit the protocol and exchange token with as many users as you can. So when you trust someone, it will be able to receive your personal token, and if he trusts you, you will be able to receive their personal token. All of this trust relation create a social graph that include direct trust. So for example, me trusting you, but also indirect trust, me trusting you and you trusting someone else. So I will be able to send token to this person because we have a trust pass between me and him. We also encourage genuine connection between each other. That's why we say that the protocol is Sybil resistant, because if there is fake avatar or someone that try to farm the Circles token by duplicating his personal account, if no one trusts him, he will not able to spend this token with someone else, so he will not be able to interact with the protocol. So for Circles avatar that I'm talking since the beginning, there is, with the new launch of Circles, there is 3 kind of avatar. There is human avatar, so it's a person like you and me. We also have group. Group, it's a group of human avatar, and group have their own Circles group tokens. And then we have organization. It's like the one step further in the protocol hierarchy. What I wanted to talk about today is the Circles SDK. So this is the SDK that is related with our Ubuntu's. If you want to apply for our Ubuntu's, you need to build something with this. It's a node package that you can install directly with npm install Circles SDK, and you can use it to build application on the Circles protocol. So with the SDK, you can create the 3 type of avatar: human, groups, and organization. For human, you, like I say, you need to get invited. So there is a function in the SDK that lets you invite an address, a wallet address, to the Circles network. And then when it's done, he can register and start to minting his own tokens as a rate of 1 token per hours. There is also a function to wrap, every Circles token is ERC 1155 token, and with the SDK, there is a function to wrap this token as a ERC 20 if you need to use it with other DeFi protocol like Uniswap or others. There is also a function to create a group. So create a group, you don't need invitation, you can do it by yourself with the register group function. And you can make your own implementation using the SDK, or you can also use our application to create and manage group. So basically, a group will have a name, a description, a symbol, and then you can add and remove people from this group. Every people from this group that trust the group will be able to get token, this group token, and interact with it. And then you can also register for an organization, but we don't have much feature implemented yet with the SDK for organization, so I will not continue with this. So the Circle SDK was designed to help developers to create communities and facilitate their economic growth. You can build any application in the Circles protocol. So there is an example in here, but we also create one for the hackathon. We create a group, ETHGlobal 2024, and if you want, you can join the group. If you come at the booth, you can join the group, and we have a leaderboard to get the swag. So you need to trust as many people as you can and to be on the leaderboard and get the swag. There is more information about the SDK at docs.aboutcircles.com. The key features of the Circles SDK is setting up an avatar, the 3 type of avatar, so personal with invitation, or group or organization. You can trust and untrust people. You can send the CRC token. So under the hoods, the SDK will see if there is a trust pass between you and the address that you want to send the token, and if it finds a trust pass, it will let the token send to this address. There is also a function to wrap and unwrap the Circles token. You can subscribe to the events from the smart contracts. There is also the possibility to build with the Gnosis Safe SDK. So if you want to build a safe application. And then we also have a migration function. If there is user from the old smart contracts, so the Circles V1, there is a function to migrate them to the V2. We have an application named Secret Garden. It's like a demo application to test all of these functions from the SDK. You can find it at app.aboutcircles.com. And yeah, if you want to get invited, like I said earlier, you can join the Telegram group or the Discord group for asking, or you can come directly at the booths. Thank you. If you have any question. Okay.